Number 6 says write a recursive formula for t minutes. The key here is that recursive formula. So a recursive formula is in the box above the definition. It's a formula for the next term depending on the previous term. So we could write it in two different ways. One is writing it in words. We could say we want our current term, the number of dots we want right now, equal to the previous term, so the one right before it. And we said in this case that we are adding 4 each time, so the previous term plus 4. And let's take a look at the table that we have over here on the right, and then we'll explain a little bit of what I'm talking about. So right here we have 0 and we have 1 dot. So if I wanted to find 1 would be our current. And to find what number of dots we have at 1 minute, we would take the previous term, which is this, and add 4 to it to get 5. Then we could take this previous term, add 4, we would get 9 to get the number of minutes at 2. And so forth as we move down our table. So another way to write that is in function notation. So for function notation, our current amount of dots we would represent as our d of t. That's our y value. Now the previous is the y value right before it. So for instance, if I was talking about the number of dots at minute 2, which was the 9, I would need the number of dots at 1, which is the previous one. So it's the t value, but 1 less than that. So I need the 1 less than that, which is the 5, before I can add the 4. So 1 less than that would give us, in function notation, d of the t value minus 1. Again, that means this d of t minus 1 is our previous term. It's just saying instead of taking d of t, we want the total number of dots for d of t minus 1. So again, if 2 was the number we're looking for, d of t minus 1 would be the number of dots at minute 1. And then we are just, again, adding 4 to that. The last thing we need for our recursive formula is to know what the first term actually was. So since I have d of t minus 1 plus 4, I need to know what the original one was. So I always have to list that first term as well. So I'm also going to list with my recursive formula that d of 0 is equal to 1. So in a recursive formula, you need both parts. You need this function notation, and then you also have to state the very first term. It doesn't necessarily have to be the 0 term. It could be the first term. Whatever term you start with is the one that's going to go here, so that we know that we're just going to add 4 starting here.